Let's take a look at problem number 18 on page 505, which is actually on assignment 50. So the problem's described this way. It says in a class of 25 students, so I put that up here, 25 students total. 8 students have heights less than 65 inches, so 8 students less than 65 inches, and 10 students have heights of 69 inches or more, so greater than or equal to 69 inches is 10 students. The probability in 18 that they're asking for is the greater than or equal to 65 inches. Well, the question that we first have to ask is, how many are between these two? Because this is less than, so 65 inches and below, that's all those students are 8. Greater than or equal to 69 inches, there's 10 of those. Well, how many are in between those two? Well, since there's 25 students total in the class, we've only accounted for 18 of them. So that means that there's 7 students between those two. So that would mean 7 students who are greater than 65 inches, greater than or equal to, because it could be 65, because this is less than. So greater than or equal to 65, but less than or equal to 69. So when I do my probability here, I'm going to have 7 students who are between these two, either at 65 but below 69, and then I'm going to have 10 more students when I put those two together. So that gives me, basically I'm taking away, if you think this is probably an easier way to look at it, all I'm doing is taking away the students, the 8 students from the 25 that are less than 65. So, and there's a total of 25. So the success is 25 minus the 8. That's another way to look at it, 25 minus the 8. That gives me 17 over the 25. And when I do that on a calculator to get a percentage, or excuse me, to get a decimal, because we want to get a decimal answer for our probability, 17 divided by 25, we get about 0.68 for our probability for that. Here's a homework problem from assignment 50. This is page 506, number 22. It says, for a science fair project, Paige wants to test whether ants prefer certain colors. She releases ants on a colored surface shown. Now this isn't exactly like that, but it's basically, this is a white circle here, this is a blue circle, and this is supposed to be a yellow circle. I don't have a yellow marker. What is the probability that any given ant will be within the blue circle but not within the yellow circle? Round to the nearest whole percent. So let's try this problem. First of all, I want to find the area of each of the individual circles. So we're going to do the area of the white circle. So the area of the white circle. So I'll put a W in that for area. And that's going to equal, the radius of the white circle is 15. So it's 15 squared times pi. It's going to be 225 pi. Now the area of the blue circle, which is the next one, put a B in there for that one. That's going to be, the radius of that one is 9, so 9 squared times pi. So you get 81 pi for that one. And then the last one is the area of the yellow circle, so I'll put a Y in that. That has a radius of 3, so 3 squared times pi. That's going to be 9 pi. So we've got the area of each, because when we're doing geometric probability, you need to find the area of them and then combine them in the proper order. Now to figure out what the probability is that it gets in this blue one, but not in the yellow, so it's in this area of it, what I'm going to do for the probability, and I'm going to put down here blue, not yellow. That's how I'll mark it, so I know what I'm talking about here. The blue area is 81 pi. That's success, but I've got to have it outside of the yellow area, so I'm going to subtract off the 9 pi circle. So that will give me, when I do that, that will give me this area here that's outside the yellow but inside the blue. I have to divide that by the total area of the entire figure, which is the white circle, and that's going to be 225, that should have a pi there, 225 pi. So let's simplify that. 81 pi minus 9 pi is 72 pi, and that's divided by 225 pi, 225 pi. The pi's cancel, so you're left with 72 over 225. And when we do that on a calculator, we get about 0.32, and it says round to the nearest whole percent. So this would be about 0.32 for our probability. So the problem here is kind of like a target problem as well. So if you ever see a problem that has targets with rings around it, you sometimes will have to figure out what a certain ring is by taking the bigger circle and subtracting the smaller one in order to get what that ring area is. Similar to this one here, that the problem that's described for, this is number 22 on page 506.